The time taken to reach the point P from the point of projection is T1. And from P to the point where he hits the ground is T2. So this much time T2, this much, it's T1. What is the height there? Half into G, T1, T2. Hello my dear students, so welcome back to Basil's Physics Classroom. And today the chapter we are going to discuss is projectiles. Now, in a brief description about projectiles, okay? Now, we two-dimensional motion chapter in the projectiles. Now, motion in a plane and the projectile motion. Okay. But one-dimensional motion, like the motion in a straight line, and the kind of class. So remember that motion in a straight line is a motion, one-dimensional motion, and motion in a plane is the so-called two-dimensional motion. Okay. But one-dimensional, only one of the axes will be changing. Two-dimensional motion, two axes will be changing, x and y, y is z, z x. So it is actually the motion taking place in a plane. Okay. The projectiles three types of projectiles are. One, we call it as an oblique projectile, ground to ground projectile. Second one, a horizontally launched projectile. And the third one, it's a projectile launched on an inclined plane. Okay. The one is an oblique projectile, then a horizontally launched projectile, then a projectile launched on an inclined plane. Okay, so let's see one by one in detail. So before moving on to learn about oblique projectile and the others in detail, let me tell you what is a projectile. Now a projectile, the basic definition it is any object thrown near the surface of the earth with a certain initial velocity at a certain angle theta, and which subsequently falls freely under the effect of gravity of Earth alone. I repeat, it is any object thrown with a certain small initial angle, theta, with respect to the horizontal or the vertical, with a certain velocity, and which subsequently falls freely under the effect of gravity of Earth alone. Okay? Now, we will look at assumptions. It is near the surface of the earth. That's G is taken to be constant. G in the variation okay. Now the second thing is earth there is a curvature for the earth. But will neglect the curvature. We neglect the curvature of the earth. Okay. And one more thing, G affect the vertical component of velocity and therefore the horizontal component of velocity will remain a constant throughout the motion. The horizontal component will remain constant throughout the motion. And the last point you have to remember, effect of gravity of Earth alone enna parnathu. Newton's law of gravitation base either. Any two objects having a mass attract each other. So we will be considering only the effect of gravity due to the earth. Moon in the effect or effect falling freely under the effect of gravity of earth alone. Okay, and air resistance neglect. That also you can remember here. Okay, in some questions specifically advanced level resistance is there. Now, we suitable to resolve this. And subsequent questions it will be clear for you. Okay. So let's start with the first one, an oblique projectile. Okay. A projectile is a common terms. Okay. So we're going to deal with an oblique projectile. Or a ground to ground projectile. Right. So I'm drawing an axis here. So I'm representing a projectile. This is projectile motion represented. It is projected at a certain angle theta with respect to the horizontal with a certain initial velocity u. This u we actually resolve. An object at an angle in the horizontal direction force height force that is what you do, right? So, we are giving it a horizontal force and a vertical force, which means the object has a horizontal component of velocity and a vertical component of velocity. Okay? Now, theta is adjacent with this side. So we can write that the side adjacent to the theta angle is taken as cos theta component, right? We can write this as ux will be equal to u cos theta and uy will be equal to u sin theta. Okay, so we can write the initial velocity like this: u is a vector quantity, velocity is equal to u cos theta I cap plus u sin theta j cap. That is the initial component of velocity. Okay, at a certain angle theta, we are launching the projectile, right? Now, when the projectile goes up, its velocity keeps on decreasing. Its velocity keeps on decreasing. But do remember that it is actually the vertical component of velocity that decreases. But the component is vertical component of velocity is the height. How does it vary? Suppose if a point angle is beta, but the velocity v. Two components, one vy, one vx. Okay. Horizontal component is taken to be a constant. So I can write vx will be the same. Change u cos theta vx. But vy will be varying. And how does the vertical component vary? Vy will be equal to uy minus gt. T, time t. Or this can be written as vy is equal to u sin theta minus gt. So the vertical component keeps on varying, and the maximum height in the maximum height. The maximum height attained by a projectile. At the maximum height, the vertical component of velocity will be 0. So what is the velocity at the maximum height? 0. Allah. Because there is a horizontal component there, right? That's constant. So maximum height velocity 0 ano? Allah. Pakshe maximum height is 0. Vertical component of velocity is 0. Vy is 0. Maximum height. Maximum height Vy is 0, but Vx is still there. So there is a velocity there, and therefore there will be an energy there also. Okay? So that's the basic based on the velocity. Now, if the velocity v, how do you write it? There two components in there. So v is actually equal to root of vx square plus vy square in there. Okay, and what will be the corresponding angle beta there? Tan beta in there. Tan beta is equal to vy by vx in there. You know what is vy, you know what is vx. Substitute in the just remember this. Okay, but v can't do vx vy substitute it. Okay, this condition at the maximum height, that is the corresponding velocity. Clear? Okay, now let's move on to something else, which is known as the range. Range in the Baranjal, it is the maximum horizontal distance. It is the maximum horizontal distance between the point of projection and the point where it hits the ground. These two points maximum horizontal distance range. And the time taken from this point to this point, from the point of projection to the point it hits the ground, is known as time of flight. The range, maximum horizontal distance, time taken is known as time of flight, and this is the maximum height. Okay, now we will see the equations and corresponding conditions. Alright, so first one, we are going to see time of flight. Capital T, which represents time of flight. Okay, now we will work on the projectile motion, and that is the initial velocity of projection and the final velocity with which it hits the ground will be equal. I repeat, the initial velocity of projection and the final velocity with which it hits the ground will be equal. Pakshe, it will be equal only magnitude wise. Direction will be different. Direction will be different, and therefore we can write is starting point maximum height in the change in velocity. If you're writing, you can write the change in velocity will be minus u. What will be that? Sine theta. Minus u sine theta. The change in velocity will be minus u sine theta j cap will be the change in velocity. Because here only u cos theta here. Here u cos theta and u sine theta is there. When you subtract it, what do you get? You'll be getting minus u sine theta j cap between the initial point and the maximum height. Now, if it is the change in velocity between the initial point and the point where it hits the ground is given by change in v is equal to minus 2u sine theta j cap. Okay? Here horizontal and horizontal it gets cancelled out. Here vertical and vertical and that is why the final minus initial. So minus 2u sine theta j cap. Okay, so change in velocity, we can also say about the change in momentum. What will be the change in momentum? The change in momentum between the initial and maximum height will be what? M multiply that, nothing else. So minus mu sine theta j cap. Similarly, between the starting point and the point where it hits the ground, change in momentum will be minus 2 mu sine theta j cap. Clear? A change in velocity and change in momentum between the corresponding points or that's a previous year question. Okay. So now coming back to time of flight. But time of flight in the പറയുമ്പോൾ അവിടെ ഓർക്കേണ്ട ഒരു കാര്യം the basic general equation for time of flight. നമ്മുടെ basic equation v is equal to u plus at use ചെയ്ത് നമുക്ക് equation derive ചെയ്യാം. And one dimensional motion the time taken to reach the maximum height and the time taken from the maximum height to reach the ground will be equal. T1 will be equal to T2. No, T1 will be equal to T2. Please remember that. Right? So we can say that the time of flight will be corresponding to 2u sine theta by g. What is the time of flight? 2u sine theta by g. And this is when we are taking the angle theta with respect to the horizontal. Okay? Suppose we consider this angle. E angle and consider the angle. It will be 2u sine 90 minus theta by g. Okay? So do remember that. Now we have brought time is equal to 2u sine theta by g. Now for two complementary angles, theta and 90 minus theta. Just like I mentioned now, we can say that for theta if time is t1 and 90 minus theta is t2, then we can say that t1 by t2 will be equal to, when you take the ratio, you will get it as equal to tan theta. Similarly, when you take the products of time of flight, considering taking into account two complementary angles of projection, t1 into theta will be equal to 2r by g. t1 into theta will be equal to 2r by g. Okay. Now another special case is, suppose we are launching a projectile like this, and this is a point P. The time taken to reach the point P from the point of projection is t1, and from P to the point where it hits the ground is t2. So this much time t2, this much it's t1. Then we can say that the corresponding height h here is equal to half into g t1 t2. What is the height there? Half into g t1 t2. Our height is half g t1 t2. Okay. Suppose another case is, suppose I have a projectile motion again described here. Point A and same level or point B. Okay. About A to B where covering our time, suppose it is t1, and another point D and C here. D to C where covering our time t2. A to B where time t1, D to C where time t2. A B same level, DC and same level. Okay. Now we can actually determine what is this height difference. This height difference y and determine based on this condition. So height difference y will be corresponding to, in terms of the time t1 and t2, t2 square minus t1 square is equal to 8y by g. And y is the vertical distance between these 2 points. So t2 square minus t1 square is equal to 8y by g. Okay, but time of flight the standard equation കൂടാതെ ഈ equations നിങ്ങൾ ഓർത്തു വെക്കണം, very very important. Okay, right. So let's move on to the next one, and that is about the range of a horizontally launched projectile. And that is the range, maximum horizontal distance between initial and final point, right? So the range is given by, range is equal to u square sine 2 theta by g. U square sine 2 theta by g. Or sine 2 theta is what? 2 sine theta cos theta. അപ്പോൾ നമുക്ക് ഇങ്ങനെ എഴുതാം u square 2 ഇവിടെ എഴുതട്ടെ sin theta cos theta by g. Or u sin theta u cos theta. അല്ലേ? അങ്ങനെ ടേം കിട്ടില്ല. അപ്പോൾ this will be 2 ux uy into g range. Okay. Now for complementary angles, when we consider for theta and 90 minus theta. Now cos theta ke 90 minus theta. Sin theta ke 90 minus theta. Cos 90 minus theta will be sin theta. Sin 90 minus theta will be cos theta. Valla change vanno illa, which means for complementary angles range remains the same. Or നമുക്ക് ഇങ്ങനെ പറയാം R1 is equal to R2 if the angles are complementary. Okay, and range will be maximum at an angle of theta is equal to 45 degree. നോക്കിയാൽ മതി sin 2 theta, sin 2 into 45, sin 90 maximum value 1. So theta 45 degree ആവുമ്പോൾ sin range will be maximum, and above range question maximum range എന്ന് കണ്ട that is a condition. Okay, and range will be equal if the angles are complementary. Clear? Now moving on to the next one, and that is regarding the maximum height. So maximum height h max. The basic standard equation is h max is equal to u square sine square theta by 2g. What is it? U square sine square theta by 2g. Now here theta is with respect to the horizontal. If it is with respect to the vertical, it will be sine 90 minus theta. Okay, so we can say that if for complementary angles theta and 90 minus theta, ഇത് h1, ഇത് h2 എന്ന് എടുക്കാം. So that will be h1 by h2 will be equal to tan square theta. You can remember this. For complementary angles of projection, h1 and h2 will be equal to, h1 by h2 will be equal to tan square theta. Okay. Another special case here you have to remember is, suppose I have a projectile motion like this. ഇവിടെ വരെ എത്ര ടൈം t1 ആണ്, and ഈ point cross ചെയ്ത time, they are actually at the same height, these 2 points. ഈ point cross ചെയ്ത time t2 ആണെന്ന് വിചാരിക്കുക. Okay, and the corresponding height is h. This is an h and equal to h ആണ്. അപ്പോൾ ഇത് ക്രോസ് ചെയ്യുന്ന ടൈം t1, ഇത് ക്രോസ് ചെയ്യുന്ന ടൈം t2 ല്. Then you can say that the corresponding height h is actually in fact equal to half g t1 t2. I hope you remember this equation. I have discussed that previously. അല്ലേ? അപ്പോൾ half g t1 t2 ആണ് the time taken to cross it. പക്ഷെ ഇവിടെ ചേഞ്ച് ഉണ്ട്. മറ്റേതെന്തായിരുന്നു? ഇവിടെ നിന്ന് ഇവിടം വരെ t1, ഇവിടെ നിന്ന് ഇവിടം വരെ t2 എന്നാ പറഞ്ഞത് അല്ലേ? പക്ഷെ ഇവിടെ അങ്ങനെയല്ല. ഇവിടെ നിന്ന് ഇവിടം വരെ t1, ഇവിടെ നിന്ന് ഇവിടം വരെ എത്താനുള്ള സമയമാണ് t2. മാറിപ്പോകരുത്. Okay, the time to cross this point is t1, the time to cross this point is t2 from the origin or from the point of projection. Okay, confusion ആവരുത്, doubt ആവരുത്. Okay, so that is the condition you can remember there corresponding to the height. Clear? Now suppose two projectiles are launched with initial velocities, one with an initial velocity u1, the other with an initial velocity u2. ഇത് a എന്ന് എടുക്കാം, ഇത് b എന്ന് എടുക്കാം. Okay, and the angles are correspondingly theta 1 and this is theta 2. Okay, in this situation, when we observe one projectile from the other, relative to each other, the motion appears to be in a straight line. A യിൽ നിന്ന് b observe ചെയ്യുമ്പോൾ അല്ലെങ്കിൽ b യിൽ നിന്ന് a observe ചെയ്യുമ്പോൾ it appears to be moving in a straight line relative ആയിട്ട് നോക്കുമ്പോൾ. Okay, and the relative position at a given instant, at a given time t, in the x direction and the y direction, velocity of a with respect to b, or the position of a with respect to b can be written like this: x is equal to u1 cos theta 1 minus u2 cos theta 2 into d. Correspondingly, y, the position distance, vertical distance y is equal to u1 sin theta 1 minus u2 sin theta 2 into d. Okay, ഈ രണ്ട് കണ്ടീഷൻസ് ഓർത്തു വെക്കാൻ. Remember that ഒരു പ്രൊജക്ടൈലിൽ നിന്ന് മറ്റൊരു പ്രൊജക്ടൈൽ ഒബ്സർവ് ചെയ്യുമ്പോൾ it appears as if the projectiles are moving in a straight line. Okay, right. Now I told you that during the motion of a projectile at the maximum height there is a velocity. അല്ലേ? Vertical component is 0, but there is a kinetic energy there. Why? Because there is a horizontal component of velocity at the maximum height. So what is that horizontal component of velocity? It is u cos theta, right? So the kinetic energy and the potential energy. How do you find the kinetic and potential energy? You know what is the velocity at the maximum height. So the kinetic energy at the maximum height will be half m u square cos square theta. Fine. And what about the initial kinetic energy? What maximum height? I'll write kh. What about the initial kinetic energy? Initial kinetic energy will be half m u square simply. So sometimes a question can come for asking you to compare this two. And theta will be given there. You'll have to compare and find the answer. Okay. And at the maximum height, we can find the potential energy also. mgh. What is the corresponding h? H max. What is the equation for h max? U square sine square theta by 2g. Okay. So substituting the value, you can get the potential energy also. Clear? Right. Now, we have to learn a very important equation here known as the trajectory equation of the projectile. Trajectory equation. Now, trajectory equation is an equation which is satisfied at each and every single point on the projectile. Okay, so any single point, suppose we are considering a point here, there will be an x and a y coordinate here. Here, there will be an x and y coordinate here. So at each and every single point, the equation is valid. And the equation is given by y is equal to x tan theta minus half g x square by u square cos square theta. Or this is also given by y is equal to x tan theta into 1 minus x by r. That's another way of representing the same equation. Okay, so do remember the trajectory equation. Suppose at this point, the horizontal distance is given, x is given, y is not known. So what do? Substitute in the trajectory equation and you will get the answer. That is a usefulness of this equation. Okay, right. And we are moving towards the end of this topic. Before we wind up an oblique projectile, two more things to remember. One, about the angular momentum of the projectile at the maximum height about the point of projection. And the angular momentum given by mvr. What is mass? M itself. V, u cos theta, the maximum height about the point of projection. Maximum height, u square sine square theta by 2g. And you can find out the angular momentum of the projectile at the maximum height about the point of projection can also be determined from here. And the second point you have to remember is, suppose an angle of elevation is given. Now, angle of elevation in the sense, this point in the maximum angle, phi. But we have a straight line, what is this angle? Phi. Angle is phi. Angle of elevation. Okay. Now, the angle of projection is theta. Then you can write tan phi is equal to tan theta by 2r. What is the relation? Tan phi is equal to 1 by 2 tan theta. So, phi is an angle of elevation. Now, projection is maximum elevation is phi and represent. Clear? So I hope all the points corresponding to projectile launch from the ground and an oblique projectile is clear for you. Okay? Now, and that is about a horizontally launched projectile. Now, horizontally launched projectile in the rainbow, it can be launched from the top of a building or a tower or anything. Okay? There are fluids applications under. And in the application and fluids partly discuss either. In the second part, I have discussed this application when we talked about hydrodynamics. About video go and watch that. Okay. Now, here horizontally launched projectile. But horizontally launched projectile is the initial component of velocity. Initial component of velocity is ux. Uy will be corresponding to 0 for a horizontally launched projectile. Initial vertical component will be 0 and the initial horizontal component will be u. U is the velocity throw that is the velocity u. Okay? About what you have to remember is, even if throw the initial vertical component is 0. നേരെ താഴത്തേക്ക് ത്രോ ചെയ്യുകയല്ല, നേരെ ഡ്രോപ്പ് ചെയ്താലും അവന്റെ ഇനീഷ്യൽ കമ്പോണന്റ് വിൽ ബി 0. ഏത് വെർട്ടിക്കൽ കമ്പോണന്റ് വിൽ ബി 0. ഓക്കെ, അപ്പൊ ഒരു ഹൊറിസോണ്ടലി ലോഞ്ച് പ്രൊജക്ടൈലിന്റെ ട്രാജക്ടറി ഇക്വേഷൻ എന്ന് പറയുന്നത് y is equal to half into g x square by u square ആണ്. നമുക്ക് ഒബ്റ്റെയിൻ ചെയ്യുന്ന ഇക്വേഷൻ y is equal to uyt plus half gt square. Okay, so that is the corresponding trajectory equation for a horizontally launched projectile. ഇനി റേഞ്ച് എന്ന് പറയുന്നത് ഇതാണ് റേഞ്ച്. ഇപ്പൊ റേഞ്ച് കണ്ടുപിടിക്കാൻ നമുക്ക് ടൈം ഓഫ് ഫ്ലൈറ്റ് വേണം. The time taken from here to here. But time of flight is given by root of 2h by g. H എന്ന് പറഞ്ഞാൽ the height from which it is dropped. From here one thing is very clear. Time of flight depends only on the height. വേറെ ഒന്നിനും ഡിപെൻഡ് ചെയ്യുന്നില്ല. അപ്പൊ ഒരു പ്രൊജക്ടൈൽ ഞാൻ നേരെ താഴത്തേക്ക് എറിഞ്ഞാലും ഇങ്ങനെ വേറൊരു കുറച്ചുകൂടി വെലോസിറ്റി കൂട്ടി എറിഞ്ഞാലും in all the cases the time of flight will remain the same. എല്ലാവരും ഒരേ സമയം ഗ്രൗണ്ടിൽ ഹിറ്റ് ചെയ്യും എന്നർത്ഥം. ഓക്കെ, അപ്പൊ ടൈം ഓഫ് ഫ്ലൈറ്റ് ഉണ്ടെങ്കിൽ നമുക്ക് റേഞ്ച് പറയാം. റേഞ്ച് ഇസ് ഈക്വൽ ടു ux into t ആണ്. ux നമ്മുടെ u ആണ്. u into root of 2h by g. That is the range of a projectile. ഓക്കെ, അപ്പൊ ഇനീഷ്യൽ വെലോസിറ്റി ux is equal to u എന്ന് പറഞ്ഞു. ഒരു എക്സാമ്പിൾ പറയാം. ഒരു എയർക്രാഫ്റ്റ് ബോംബർ പ്ലെയിൻ ബോംബർ ഇസ് ഗോയിങ്, ഒരു ബോംബ് ഡ്രോപ്പ് ചെയ്യുന്നു. ഈ ബോംബ് ഡ്രോപ്പ് ചെയ്യുമ്പോൾ നേരെ താഴത്തേക്ക് വീഴുവോ? ഇല്ല, ഇനേർഷ്യ അല്ലെ. അപ്പൊ ഇനേർഷ്യ കാരണം ബോംബർ പ്ലെയിൻ ഇങ്ങനെ പോകുന്നത്. അപ്പൊ ബോംബ് ഡ്രോപ്പ് ചെയ്യുമ്പോൾ എന്ത് പറ്റും? നേരെ താഴത്തേക്ക് വീഴുന്നതിന് പകരം ബോംബ് ഇങ്ങനെ പോയി വീഴും. ലൈക്ക് എ പ്രൊജക്ടൈൽ, റൈറ്റ്? ഹൊറിസോണ്ടലി ലോഞ്ച് പ്രൊജക്ടൈൽ. Now ഇവിടെ നമുക്ക് എഴുതാം റേഞ്ച് എഴുതി, ടൈം ഓഫ് ഫ്ലൈറ്റ് എഴുതി, y എഴുതി, ട്രാജക്ടറി എഴുതി. Now one more thing we can write there is the velocity after t seconds, and the velocity v is equal to root of vx square plus vy square. അപ്പൊ vx ന് ചേഞ്ച് ഇല്ല, അത് ux തന്നെയാണ്. അപ്പൊ u square vy it is changing. vy is equal to uy 0 ആണെന്ന് അറിയാം അല്ലെ. അപ്പൊ gt, so it is gt the whole square. So the velocity after time t is given by root of u square plus gt the whole square. Clear? That is the case of a horizontally launched projectile. Okay, before we wind this up, one more thing to remember there is, നമ്മൾ ഈ ഒരു ബിൽഡിങ്ങിന്റെ ടോപ്പിൽ നിന്ന് ഒരു ഒബ്ജക്റ്റ് നേരെ മുകളിലേക്ക് എറിഞ്ഞു, ഇങ്ങനെ പ്രൊജക്ട് ചെയ്തു, നേരെ താഴത്തേക്ക് എറിഞ്ഞു, പല ആംഗിൾസിൽ പ്രൊജക്ട് ചെയ്തു. ഓക്കെ, നൗ ഹിയർ one thing will always remain the same. എന്താന്ന് പറയാമോ? Here the velocity with which these different projectiles are hitting the ground, എല്ലാവരും ഗ്രൗണ്ടിൽ ഹിറ്റ് ചെയ്യുന്ന വെലോസിറ്റി സെയിം ആയിരിക്കും. അതിനുള്ള റീസൺ ഞാൻ വൺ ഡയമെൻഷനിൽ പറഞ്ഞിരുന്നു. ഇനീഷ്യൽ വെലോസിറ്റി പ്രൊജക്ഷനും ഫൈനൽ വെലോസിറ്റിയും സെയിം ലെവൽ എത്തുമ്പോൾ സെയിം ആണ്. അപ്പൊ ഇവിടെ നിന്ന് എറിയുന്ന പ്രൊജക്ടൈൽ ഇവിടെ തിരിച്ചെത്തുമ്പോൾ അവർ രണ്ടുപേരും വെലോസിറ്റി എന്താണ്? സെയിം ആണ്, ഈക്വൽ ആണ്. വിച്ച് മീൻസ് ഓരോ പ്രൊജക്ടൈലിന്റെയും എങ്ങനെ എറിഞ്ഞാലും ശരി സെയിം ഹൈറ്റിൽ എത്തി കഴിയുമ്പോൾ അവന്റെ വെലോസിറ്റി ഈക്വൽ ആവും. Then it is coming downward. അതിന്റെ അർത്ഥം when they hit the ground the velocities will be equal. ടൈം ഈക്വൽ അല്ല, ഇവരുടെ എല്ലാം ടൈം ഈക്വൽ ആവാം, പക്ഷെ ഇവന്റെ കമ്പയർ ചെയ്യുമ്പോൾ ഇറ്റ്സ് നോട്ട് ഈക്വൽ. ഓക്കെ, സോ വെലോസിറ്റി വിത്ത് വിച്ച് ദേ ആർ ഹിറ്റിംഗ് ദ ഗ്രൗണ്ട് വിൽ ബി സെയിം. ആൻഡ് ആദ്യം ആരാ എത്താൻ പോകുന്നത്? നേരെ വെർട്ടിക്കലി എറിഞ്ഞ പ്രൊജക്ടൈൽ. ഐ ആം ഡ്രോയിങ് എ പ്രൊജക്ടൈൽ വെർട്ടിക്കലി ഡൗൺ, റൈറ്റ്? അപ്പൊ ഏറ്റവും ആദ്യം എത്താൻ പോകുന്ന അവനായിരിക്കും. ബാക്കി എല്ലാവരും റീച്ച് ലേറ്റർ. ഈ ഹൊറിസോണ്ടലി ലോഞ്ച് പ്രൊജക്ടൈൽ ഉണ്ടെങ്കിൽ ഈ ഹൊറിസോണ്ടലി ലോഞ്ച് പ്രൊജക്ടൈലും ഇവനും ഒരേ സമയത്ത് എത്തും അല്ലെ? വാട്ട് ഈസ് ദ റീസൺ? ദ റീസൺ ഈസ് ഈ ഹൊറിസോണ്ടലി ലോഞ്ച് പ്രൊജക്ടൈൽസിനും നേരെ താഴത്തേക്ക് എറിഞ്ഞ പ്രൊജക്ടൈലിന്റെയും വെർട്ടിക്കൽ കമ്പോണന്റ് is actually 0 initially. That is the reason. Clear? Okay, so that is about a horizontally launched projectile. Now let's move on to the third one, and that is a projectile launched on an inclined plane. Projectiles on inclined plane. Okay, നമുക്കൊരു inclined plane വരയ്ക്കാം. ഇവിടെ inclined plane angle theta എന്ന് എടുക്കാം, or maybe I'll take it as alpha. It is projected at a certain angle, a projectile. We'll take that angle as theta. Okay, a projectile is projected at an angle theta with respect to the inclined plane, and the angle of the inclined plane is what? Alpha. അപ്പോൾ ഇവിടെ നമ്മൾ ഓർക്കേണ്ടത് ഒരു ചെറിയ ഒരു റെസൊല്യൂഷൻ ഉണ്ട്, ഇവിടെ റിസോൾവിംഗ് ഉണ്ട്. നമുക്കറിയാം ആക്സലറേഷൻ ഡ്യൂ ടു ഗ്രാവിറ്റി is always acting downwards, അല്ലേ? Right? So we are actually going to resolve this. And ഇങ്ങോട്ടും ഓരോ കമ്പോണൻസ് വരയ്ക്കുക. So this will actually be correspond with alpha ആണ്. അപ്പോൾ ഇത് 90, ഇത് 90 minus alpha, this will be alpha, this will be g cos alpha, and this will be minus g sin alpha. Now, ഇത്രയും നേരം പഠിച്ച projectile motionൽ one thing you might have noted is horizontal component is not affected by gravity. പക്ഷേ ഇവിടെ along an inclined plane വരുമ്പോൾ along the horizontal direction of the projectile, ഈ projectileന്റെ horizontal directionൽ ഒരു accelerationന്റെ component വന്നു minus g sin alpha. Vertical direction law g cos alpha. Okay, so now based on this, let's find out what is the corresponding equation for the range, h max, and the time of flight. Okay, so again, time of flight t. T will be equal to, ഓർത്ത് വെക്കാൻ വളരെ എളുപ്പമാണ്. ഓക്കെ, എങ്ങനെ ഓർത്ത് വെക്കും? 2u sin theta by g നമ്മൾ പഠിച്ചിട്ടുണ്ട് അല്ലേ? അപ്പൊ ഇവിടെ എഴുതാൻ പോകുന്നത് 2u perpendicular, 2u perpendicular divided by g perpendicular. ഓക്കെ, u perpendicular എന്ന് പറഞ്ഞാൽ ഇതിന് പെർപെൻഡിക്കുലർ ആയിട്ടുള്ള കമ്പോണന്റ്. ഐ എം ലോഞ്ചിങ് ഇറ്റ് വിത്ത് u. ഫൈൻ. അപ്പൊ ഈ കമ്പോണന്റ് എന്ത് വരും? u sin theta. ഫൈൻ. u sin theta with respect to the inclined plane, u sin theta. Okay, so this will be, and g perpendicular and the g cos alpha. So this will be time of flight is equal to 2u sin theta by g cos alpha. Okay, time of flight. അതുപോലെ ഓർത്ത് വയ്ക്കാം. അതുപോലെ range number h പറയാം. Maximum height will be equal to, ഇതാണ് നമ്മുടെ maximum height. That will be corresponding to h is equal to u square perpendicular by 2g perpendicular, or you can write this as u perpendicular and the u square sin square theta divided by 2g cos alpha. So you have the equation for h max also. Okay, ഇനി വേണ്ടത് എന്താ? range in equation. And the equation for range in equation എങ്ങനെയാ? Range is given by 2u square by g sin theta cos theta plus alpha by cos square alpha. Okay, അപ്പോൾ ഇത് ഓർത്ത് വെക്കണം, ശ്രദ്ധിക്കണം. It's a big equation, you might get confused. Okay, അപ്പോൾ ഇത് ഓർത്ത് വെക്കുക. റേഞ്ചിന്റെ ഇക്വേഷൻ. അപ്പോൾ ടൈം ഓഫ് ഫ്ലൈറ്റ് പറഞ്ഞു, h max പറഞ്ഞു, range പറഞ്ഞു. And here also we can talk about the condition for maximum range, r max, u square by g 1 plus sin alpha. What is it? u square by g 1 plus sin alpha. Okay, so suppose the inclined plane is inclined downwards, താഴത്തേക്കാണ് inclination എങ്കിൽ r max will be equal to u square by g 1 minus sin alpha. Okay, and you can write theta is also angle is actually corresponding to theta is equal to pi by 4 minus alpha by 2. Okay, the angle at which the range is maximum. Clear? So we have discussed about horizontally launched projectile and oblique projectile and about a projectile on an inclined plane. Okay, so I hope these conditions are clear for you. So in case you have any doubts you want to ask me about, please do feel free to comment below and do subscribe to the channel Basis Physics Classroom. Okay then, thank you.